All right, so now we're going to do if we're doing cube root problems. So whenever we're doing cube root problems, it's very similar to the ones we just did with square roots. So we need to isolate the radical. So here, this is our radical. It's not isolated, meaning that this plus 5 is on the same side of the equation. So I need to move that first. I get the cube root of x equals -2 then. Normally, if this was a square root of x, I would be done and I would write no solution, but cube roots, it's okay for it to be negative. The inverse of a cube root is to cube both sides. So I cube both sides. This cube root and cube cancel each other out. So I just am left with x. -2 to the third is -8. So then x equals -8. I should check it. So I plug it back in to the original problem. The cube root of 8 is -2 if I look at the calculator. And when I add 5 to -2, I do get 3. Now this one's different because the x plus 5 is in the radical. And just like I said before, that the radical is like a box. So the x plus 5 is stuck inside the box. You can't move the 5 until you open the box or get rid of the radical. And the way you get rid of the radical is to cube both sides. So I'm going to cube both sides. That cube and cube root disappear. That means the box is open. So it just becomes x plus 5. I don't do 5 to the third power. A lot of you have been doing that and getting 125 here. You don't do that. The cube and the cube root, they cancel each other out. So you don't have a cube left over there anymore. So it's just x plus 5, and then 3 cubed is 27. And I subtract 5 like I'm back in algebra 1. I just solve and I get 22. I should always check my work. So I'm going to plug that back in. The cube root of 22 plus 5 equals 3. 22 plus 5 is 27. The cube root of 27, if we plug it in our calculator, it does equal 3. So that works.